Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and a very good morning. I'm Norhayati Binti Jamil from Polytechnic Sultan Azlan Shah, Perak. Today I would like to present my research on the buckling of cold form lip C section subjected to compression load. Now I would like to share my presentation slides. Okay. For introduction, I would like to present on cold form steel members, which is fabricated from carbon and high strength sheet steel. Strip plate and strip flat bar have been used widely in various types of structures. Cold form steel sections have extremely wide range of applications in modern industry. They are used in the manufacture of buildings, automobiles, road and rail transport, aircraft, ships, storage systems, as well as in many types of office, industrial, agricultural, electrical, and domestic equipment. So the figure here, we have three figures, which is the comparison between plain C section, okay, and the next one is lip C section. The last one is the intermediate C section. The objectives of study, which is the first one, I would like to look at the behavior of a buckling cold form C-section column under a compressive load, and then the failure of local buckling in the columns. The next one is the buckling load of the column compared between C-section and lip C-section, and the next one is the deflection, lateral and vertical displacement during buckling. The next one is the comparison of the experimental and theoretical of the buckling load and deflection at the different lengths with a constant size of the column. And the last one is the comparison between with stiffness and without stiffness. Scope of the study is for my research is the testing was carried out using cold form lip C section column and lip C section. Okay, where both of the ends are pin supported and subjected to compressive load. The sections remain in size of 25 mm times 50 mm for C section and 25 mm times 50 mm times 11 mm for lip C section with various effective lengths and loads. This research was to find the buckling behavior of buckling C-section and lip C-section member. Mode of failure in terms of local buckling will be considered in experimental of compression members. Actually, the specimen is to consider the testing, which is I'm using a BS 5950 part 5. Okay, from BS British Standard 5950 part 5. I have to test on tensile test, which is that this tensile test was carried out to determine the Young modulus of elasticity in accordance BS 1987, and we considered on method for tensile testing for metals, including aerospace materials. And the next one is compression test. This testing was carried out to determine the strain and the deflection. The specimens are clamped to the jig pin supported at both ends, so it can allow the column to rotate freely when the buckling load occurs during testing. For the literature review, the cold form is the term used to describe the products by forming material in the cold state from a strip or sheet of uniform thickness. There are a variety of different methods of forming used for cold form products, but the main methods for structural members are folding, press backing, and rolling. Compared with other materials such as timber and concrete, the following qualities can be realized for cold form steel structures members, which is lightness, high strength and stiffness, ease of fabrication and mass production, fast and easy erection and installation, substantial elimination of delays due to weather, more accurate detailing, non-shrinking and non-creeping at ambient temperatures, formwork unneeded, termite proof and rot proof, uniform quality. All of this is a combination of the above mentioned advantages can result in cost saving during construction. My methodology, which is principle to design the members and structures of cold form steel, the analysis as set up in BS 5950 Part 5 1987 will be used wherever possible. A number of situations where analysis according to code of practice is not possible or where a better understanding of the behavior of structures can be obtained by virtue of testing. This testing was to determine the critical buckling load and deflection. For preparation of testing specimen, there are two types of testing that carry out in the material research laboratory. The testing that had been carried out are such as tensile and test coupling and compression test. Right, this is the sample of the specimen. Shows for A, figure A is for C section with a dimension given. And for the lip C section on figure B with the web, flange and lips. Okay. This is the methodology according to the apparatus, which is I had using a loading machine instrument model 4206. Yeah. Okay. The next one, I use the transducers and data logger, which is the model is DT-100A, was used to measure and record the result to the data logger model UCAM-70. And the next one is Extensometer. Extensometer was used during tensile tests. It was used to measure the extent of the test coupon in the thickness of applicable of a plate which was caused by tensile. And the next one, I use also the jig testing, which the purpose of jig is to support the specimen during the compression test. Vertical support needs to, for each cases, to restrain the inside flange of the column and prevent twisting. For force in column, the purpose is the connections where it is considered as pinned. Okay, I have to design the jig. Okay, so the condition for the jig is we have a base plate, connecting plate, and end plate. Okay. The next one, for testing procedures, I use the test specimens. Okay, and the next one is a tensile test. Okay, this is the figure on test piece for coupon test. Yeah, with the dimensions given. Okay, for compression test, so I have to use actually the specimen was cut in the same size, which is dimension given 25 mm times 50 mm thickness. Okay, and also for several lengths that the length I've using is 5 different length, which is 250 mm, 400 mm, 500 mm, 550 mm, sorry, 500 mm and 600 mm. Okay. And the next one is for the testing procedures. Actually, the specimen were placed in the position according to the test required, buckling. Okay, and a small load was applied so that the specimen can settle down. Okay, the unloaded was slowly removed. This is more to the procedures for the testing actually for compression test. Okay, okay, this is the figure shown for apparatus used in the experiment. Okay, this is a data logger instrument model. Okay. On my left is a water balancing, and on my right is a jig. Yeah. Okay. So I have to take the reading every 0.1 mm per second. Okay. Okay. This is the sample with a different length that I have tested for compression test. Okay. If you can see here in figure 1.12, with a load, we have you can find that the column buckle, and this is the data that I found from my test for 3 specimens. Okay, so for modulus elasticity, If you can see here, for specimen 1, the young modulus is 108.65. For specimen 2, 143.75 young modulus, and for specimen 3, 128.75, and the average is 127.05. Okay, for yield stress, the specimen for average for the 3 specimen is 0.557. Okay, this is the graph for the load versus displacement for specimen 1. This is the graph for specimen 2. Okay, and this one is a graph for specimen 3 to look at the displacement. Okay, here I'll share with you my results on compression test. Okay, for different on 5 kinds of length here. So we can see here for ultimate buckling loads result is happened in for a start here. Okay, for length 250, the high results buckling happen is 55.2. Okay, this one is for the ultimate buckling load for lip stiffened C-section. Okay, if you can see here, the figure, the average of buckling happened on the same size, which is for length 250, which is average 39.18, the most buckling column. Okay, this one is for vertical displacement for lip stiffened C-section. Okay, if you can see here, for vertical displacement, okay, the most displacement happened for specimen length 600 here, which the average is 658 millimeter displacement. And this one is the analysis and discussion. Okay, if you can see here, for the 5 different types of length. Okay, for theory and experiment, if you can see here, they have a percentage of different, which is the most different is for the length of 250 mm. Okay. Okay, this one is the comparison displacement between stiffened and unstiffened section of web for length 250 mm. This is the graph shown that the comparison for the displacement, and this one is the comparison displacement between stiffened and unstiffened section at flange. The first graph that I have shown to you is for at web. Okay, this one at flange. Okay, this one is the comparison displacement between stiffened and unstiffened section at web for length 600 mm only. Okay, and this one is for flange at 600. Okay, actually I've used LUSAS also to look at my analysis to differentiate between I've done with the correct apparatus with LUSAS, and the result and discussions, the result obtained from experimental, theoretical, and computer analysis LUSAS are presented in the form of load against displacement. There is a large difference of the results obtained in LUSAS and 3% and 3% to 20% obtained in calculation for the tested specimens. Stress-strain relationship is in linear behavior of the column structure, and typically it represents compressive stress. All the stresses obtained were compressive stresses, and in LUSAS the middle nodal had been considered. The graph plotted based on the lab testing, calculation, and computer analysis result. The estimated load that cost be adopted. This is because the suggested value is before critical loading or estimated load. So the Deflection increased slowly until as the load reached its strength. A linear behavior is observed before the first buckle due to change stiffness in the structure itself. The computer analysis losses result in large difference in displacement and stress and strain for the experimental result. The cause of the differences is because of the error during input experimental and computer analysis are not plotted because of the bigger difference between them. Due to large difference in terms of displacements between computer analysis and experimental, therefore the losses program has to be devised. Okay, this is some of conclusion and recommendations from my study, which is the deflection occur at the middle for certain length in experimental. The deflections occur at mid-column for calculation. The deflection occur at mid-column for computer analysis losses. The average percentage difference for modulus of elasticity E between experimental and calculation is 25%. Due to the large difference in terms of displacement between computer analysis and experimental, therefore the losses program have to devise in order to obtain iterated modulus of elasticity. And from the results, I can conclude that the losses program and calculation is cannot similar compared with experimental. Okay, this is some of my recommendations. Okay. This is the manufacturer that I've been to get the material, which is Juta Steel Syndrome Berhad and the Silica Syndrome Berhad. Okay, that's all for me. Okay, thank you and Assalamualaikum.